Hello students and welcome back to my channel. I am discussing physics questions based on modern physics which were asked on 31st January 2023 JEE mains. Okay. Coming to the first question, given below are two statements, one is labeled as assertion A and reason R. A beam of electrons show wave nature and exhibit interference and diffraction. This is true students because electrons exhibit dual nature. Okay, in certain situations they exhibit wave nature and in certain situations they exhibit particle nature. And Division and German experimentally verified the wave nature of electrons. This is also true. It was for the first time that Division and Germer, who were basically the lab assistants of Rutherford, they experimentally verified the wave nature of electrons. So A is correct and R is also correct, and R is the correct explanation of A. So B option is the correct option. Moving to the next question. If metals A and B are exposed to radiation of wavelength this much, work function of metal, then choose the correct option. Now let us calculate this, the energy corresponding to the wavelength of this. So energy is 12400 upon wavelength in angstrom. This you'll get in electron volt. This is the shortcut to calculate the energy of a photon if you know the wavelength. So this will be somewhere around 3 point something. Okay, because 3 3 is a 9, so it will be 3 point something electron volt students. Now as you can see, if work function is more than the energy of the incident light, then photoelectric effect cannot be observed. Whereas if work function is less than the energy of the incident photon, only then you can observe the photoelectric effect. So metal B will show photoelectric effect, but not A. Here B option, that is metal A will not emit photoelectrons because its work function is more than the energy of the incident light. The next question, a free neutron decays into a proton, but a free proton does not decay into neutron. This is because, as you know, neutron is slightly heavier than proton. If a free neutron could decay into a proton, that is quite natural because a heavier mass can split up into lighter masses. But what about this? A proton becoming a neutron, it has to absorb mass, and that is not possible. A free proton means there is nothing there other than the proton. So in order to get converted into a neutron, it will require additional mass, which is not possible. So that is the reason. So neutron has larger rest mass than proton. Then the radius of the second electron's second stationary orbit of Bohr's orbit is this. Radius of third orbit will be. Now it's a question based on Bohr's atom. Now students, you have to understand two things. One is according to Rutherford's theory, the centripetal force is provided by the electrostatic force of attraction between the electrons and the protons. So we have mv square r is equal to k into z square. Then according to Bohr's concept, the angular momentum of an electron is equal to n times h by 2 pi, where n is the principal quantum number. Okay. Now, if you want to know V, okay, you can simply divide 1 by 2. Then V, you can see, will be proportional to Z by N. Then, if you want to know R, square 2 and then divide by 1. Squaring 2 and then dividing by equation 1. Then here V square will get cancelled and we will be left with R. So this will be N square by Z. Okay. So here we have to find the radius. So we will be using this formula. So radius of third orbit, radius of second orbit is R. So we can write Radius of third orbit upon radius of second orbit is equal to 3 by 2 whole square. Okay. For bohr atom Z is equal to 1 always. So R3 is 9 by 4, that is 2.25 times of R. D option is the correct option. Then for hydrogen atom, lambda 1 and lambda 2 are the wavelengths corresponding to the transitions 1 and 2 as shown with the ratio of lambda 1 and lambda 2. You can see students, transition 1 is from n equal to 3 to n equal to 1, whereas transition 2 is from n equal to 2 to n equal to 1. So corresponding wavelengths are given. We have to find lambda 1 by lambda 2. Now, for 1 by lambda 1 is equal to Rydberg constant into 1 minus 1 by 3 square, which is 8 by 9 Rydberg constant. Then 1 by lambda 2 will be Rydberg constant into 1 minus 1 by 2 square, that is 4. So we have 3 by 4 times of Rydberg constant. So dividing 2 by 1, we have lambda 1 by lambda 2 is equal to 3 by 4 into 9 by 8, which is 27 by 32. So this must be 27. Then moving on to the next question. If the binding energy of ground state electron in a hydrogen atom is this, then the energy required to remove the electron from the second excited state of this. Now, energy required to extract an electron is from hydrogen like atom is this. This is the formula, where Z is the atomic number of the element and N is the orbit number. So this will be 13.6 electron volt. For lithium, atomic number is 3, and we have to extract it from the second excited state. Second excited state would mean the third orbit. So this remains 13.6 itself, but we have to express in terms of 10 power minus 1. So this will be 136 into 10 power minus 1. So 136 is the answer here. That's all students in this video. Thank you so much.